Hello everyone, my name is Brian Locke and today I've got a new type of video for you called ProtoType Playground. And it's called that mainly because I love alliteration, but also because I've got this pop filter and I really want to make use of it. So in this video I'm going to talk about an idea I had for a project and then the prototype I came up with to achieve that idea. So this is actually something that I built 6 months ago and I haven't actually touched it since, so hopefully it still works and I can remember everything that's going on. But let's jump into it. So here's a picture of me on my way to work. I'm driving away from my house, but unfortunately in my house is my wallet. This is something that happens to me quite a lot, so I actually wanted to come up with something that would remind me that I don't have something that I need for the day. And this is actually an idea that I came up with maybe even 10 years ago, well before I was into Arduino, but I had no idea how to solve it. I was thinking maybe like RFID tags or something, but they don't have the range for that kind of thing. But I came up with this solution that I'll demonstrate now. Okay, so let's take a look at what's inside. So we have it labeled Wemos and BT40. Okay, so we have a breadboard with a Wemos D1 Mini and some jumper wires, and we have a loose Bluetooth module. Also, I remember from this project that I used to have an OLED screen, and I'm not sure where that is, so we better get a new one of those. This is my repurposed frozen loom band kit. I literally bought this just for the box, I swear. Okay, so it was an OLED screen. Yeah, this guy. So they were the three components. Now we have a problem that both of these sides have 4 cables going into them, and I don't remember which one is which. Also, one thing I see that's kind of strange is that only the 5-volt connection is hooked up, not the 3.3 volts. I know the Bluetooth module is 3.3 volts, logic anyways, but I'm pretty sure it has a voltage regulator built into it. The screen I thought was 3.3 volts to power, but maybe it also works with 5 volts, so maybe we'll just take a chance and see how that goes. Okay, but I think I'm going to need to look at the sketch to find out which one to plug this into, just to make sure that there's no issues with that. Okay, so from the sketch it says that the display is plugged into D6 and D7. So that means the display is down the bottom here. Only be plugged in one way, so I don't need to be too worried about the connections. I'll just double check. This green wire is plugged into 5 volts, so yeah, that looks good. Now, this one has more connections than I have pins for, so I need to double check what we're doing here. So VCC is here and orange is 5 volts, so I guess we're plugging in there. I guess we don't need the enable pin. Okay, let's power it up and see what happens. Wish me luck. Well, my computer recognized it and it's searching for devices, and it found my badge, which I'm surprised about. It is near me, but I'm surprised the battery still works in it. and it's searching for my wallet. Still searching. And my wallet is missing. My wallet is also near me, so maybe the battery is gone on that one. Okay, so what it's doing is it's searching for these, which are Bluetooth trackers that you'd put on your keys or whatever, and you'd connect it up to a phone app, and your phone app can be used then to make these make noise so you can find them, or even kind of track them down or let you know where you last left them. So Tile would be a popular one, or Track, but this is a cheap one from AliExpress. It's not the cheapest one from AliExpress. I did buy one of those, and I'll link to that in the description or put a picture here. You don't want to buy that, it's awful. These ones I think were $7 or $8, and they work pretty good, so I'd recommend those ones. And also my wallet. Oops, I seem to be knocking everything. So here is the tracker for my wallet. Now also I might notice that I took out my ID card in case anybody was giving out to me for displaying it, so I don't actually work for Curry's and I'm not a gift card. Okay, so let's swap out the battery on this guy and see, does that fix the problem. So it is that's another actually nice thing about these nut trackers, is that the batteries are replaceable. Now they don't last as long as the bigger brands, but like that wallet one has been working since February. It's now August, so can't really complain too much. Okay, so it is CR 2016, which I have. Okay, awesome. Probably should have remembered which way that went in. Probably this way. Oh, okay. Seems to have battery now anyways. I don't know if you heard that, but it beeps as soon as I plug the battery in. So this thing only worked on startup. So if I reset it here, we'll see what happens. So I have a pretty crude understanding of how these things work, but I'm pretty sure they wake up, emit where they are, and then go to sleep. So what this does here is it continuously searches for a set amount of time. I think it's maybe like 30 seconds until it finds all the devices that it's looking for. And so it found the two devices here. I don't know if you can see the screen. Oh, the wire's in the way. I still didn't get it focused. This is actually a lovely and crisp display if you're looking at it in person and not through a camera. Okay, that works okay. So as you can see there, badge, okay, and then the figure after it is -32. And what that is the intensity that it finds the module at. So it kind of shows how close it is or whatever. Then the other thing then is the wallet, and that is at -35. So it's not an exact science to how close these things are. So I'm searching on a range. Okay. Okay. No, I kind of panicked there. My camera was telling me that I only had a minute left of recording, and I have no idea why. Okay, so it searches for the devices. These things admit that they're here, and they're not paired or anything. It's just basically the Arduino knows the address, the Bluetooth address of this. So if it detects something emitting a signal from the known address, and it knows its power intensity. So if it's below a certain threshold, it says that it's okay. And then if it's missing, it'll search for those 30 seconds, see that it wasn't there, and show up that it was missing. So the other thing that might be kind of interesting is that for me, like, my car is right outside the front of my house, so if I turned on this device and maybe my wallet was inside, it would still be able to see it. But I tried to handle for that in code, and I'm just going to cut away here and put this tracker down in the other end of the house. Nearly got given a job there. Okay, so I'm going to reset again now. So that was the wallet one. So we're going to be searching for devices. Okay, so as you can see there, the wallet is low. And I can't fully remember, but I think that I keep searching until it's okay. Or maybe I just, yeah, so it changed intensity there. So it keeps searching until it finds it close, or finds a signal that's strong enough for it. So this will say that it's low, and it'll continue to search until the 30 seconds are up. So this would let you know that that badge is too far away, or sorry, the wallet is too far away for what you'd expect in your car. Like, you know, it should be pretty close by. So that's pretty much a demo of it. So let's take a look at the horrible code that makes this work. Before we look at the sketch, let's first take a look at the hardware. I'm using a Wemos D1 Mini, which is obviously an ESP8266 board, but any board will work here because I'm not even using the Wi-Fi functionality. One thing to note though is that the Bluetooth module is 3.3 logic level, so if you're using something like an Uno, you'll probably need a level shifter, or you'll need to use voltage dividers. So the Bluetooth module is this AT09CC2541 module that I flashed with custom firmware, and I'll talk about that in a second. And then the last thing is one of those OLED screens. I like these a lot because there's only 2 data wires that's needed, and then just power. To flash the custom firmware onto the Bluetooth module, I followed a guide by a user called Hexer on the Arduino forums. It was pretty straightforward. The only challenging thing was soldering directly to the Bluetooth module pins rather than the broken out header pins. But other than that, it was pretty straightforward to just follow the guide. Just take note, as mentioned, that it's a 3.3 logic level Bluetooth module, so if you're using an Uno to program it, you're going to need a logic level shifter. I'll link to my video talking about this up above here. Okay, so let's look at the sketch here. I was getting kind of worried because in a folder I had cleverly named Bluetooth, I had one called BT with screen, and that did not contain this code whatsoever, but cleverly this one was named working, and this was what was working for me. So I pull in just a couple of libraries, the software serial, which actually probably technically isn't needed. You could connect directly to the serial of the Arduino, but for testing purposes I was sending in serial commands using the serial monitor, and then using software serial to communicate from the Wemos to the Bluetooth module. And then these are just libraries needed to run the OLED. For some reason that I don't understand, I have the pins defined using the ESP8266 GPIO pin numbers rather than the Node MCU or Wemos pin convention, which would be D something. But it's working, so I'm not too worried about it. And then I just create the BT serial. And then I just have the configuration for the OLED. So this is where it gets a little bit more interesting. I have the Bluetooth addresses of the 2 different NUT devices. I think I found these using an app on my phone called like BLE Scanner or something like that. So yeah, you'll need to get them so you know what devices you're searching for, because you know it could find things like your Fitbit or any sort of fitness tracker like that. So you want to be able to identify what it's looking for. So I create an array of known devices, so it's the name that showed up on screen, badge and wallet, and then obviously the address of each of them. So note 1 has, which is the badge, has this address, and so on. I have no idea what 0 is. 0 is power. Okay. No idea what that's about. And then the -70, so is the threshold. So if it's closer, it'll be a bigger number, but these are all minus numbers, the power threshold. So when we saw like -35, that's a bigger number than -70. So if it's further away, like when we were looking, I think it was 80 something, so that would have been outside the threshold. So this can be configured to whatever would work for you, and then it defaults the found value to false. So when we find it, I'm pretty sure we set it that this would be true, which means we'll stop looking for it. Actually, power is probably the last red value. It's just stored in there. Maybe I should name that variable something better, but this is a pretty hacky code. So yeah, in the setup we just initialize the screen and say that we're searching for devices. We set up the software serial. We have a loading bar apparently that we don't use. Okay, so we do 8 of these searches. I don't think there's any rhyme or reason to that other than just that that's what looked pretty decent. I'm not too sure, to be honest though. So send discovery, we'll look at that in a second. So basically I think what that's doing is it's searching for the devices, and then if it finds as many devices as are in the known device count, which we set to 2 up here, it'll break out of this for loop, because we don't need to search anymore, and it'll be finished its search, and we don't need to display devices anymore. I'll check what that is now in a second. Okay, so let's take a look at the send discovery method. So it sends a AT command, which is AT plus disi ? To the Bluetooth module, and it waits for its response and puts it all into this response variable. So when the response is finished, it checks for I think a new line character probably. It will parse out the contents of the response. So regardless of what was contained, if it was a valid response, it should have this string at the start and a string at the end, which is of a known value. So what we want is the content of that to see is there any interesting data coming back. So we use the substring, and for some reason I use an 8 rather than the actual length of the start, like I do with the length of the end. Who knows why? I even have length of start method or variable that I don't use. Who knows? So yeah, we get the response back, and it will look like this then, which you can see has some data in it. So if the response length is greater than 0, we create an array of devices, 16 of them for some reason. I can't remember any of why, but so each device has a specific structure that the response will come back in. So this time we found 3 different devices, and the start of the information of each device is marked by this OK plus disk part of the message, and then there's additional information after that. So what we want to do here is parse out each device from this string and populate the data into the array that we saw earlier. After that, it's just a case of handling the logic of if it was close enough to the threshold or not, and then also just displaying the information to the screen. So what's the future of this project? So the current state is that I got a fully working prototype that achieved the goal. Like, that device can be plugged into my car now, so when I turn on my car, the device will turn on and it will search for the items such as my wallet and my badge. It is not under active development, which I'm sure you're not surprised about if it's been sitting on my shelf for 6 months. But if it is something that people would like to see kind of finished off, or a guide written up on how to do it, please let me know, and maybe we can make it happen. So another thing to consider would be future improvements. I think adding a buzzer to let you know audibly that there's something wrong, or maybe that it's right, so you don't have to be looking at the screen to see that there's a problem. And the other thing that would be useful is a Wi-Fi config mode, so you can add devices, through a web interface rather than having to reprogram the device. Okay, that's it for today's video. Let me know what you thought about the project, or even, is there anything that you would change, or would you approach the problem a completely different way? I'd be really interested to know your thoughts. Also, this is a much different video than the ones that I normally do. It's a lot less edited and more ad hoc, so I'd be interested to hear, do you have any feedback on these as well? Like, do you prefer this type of video to the more scripted ones, such as the 2-minute tidbits? I'd like to do a mixture of both, but depending on what you like best, it would probably be what I'll end up doing more of, so your feedback would mean a lot. So I'm going to leave it at that. Thanks a lot, guys.